In the previous lesson, we had the sum and the difference rules. Those are nice because it just says if you have the sum or difference of two functions, you just find the derivative of each and then you add or subtract the derivatives. With products, that doesn't work. So I have the question. I know I'm telling you ahead of time it's not going to work. But it says, does the derivative with respect to x of the function f times g of x. So this is just another notation for f of x times g of x. And it says if you take the derivative of that product, does it equal f prime times g prime? So can you take the derivative of f and the derivative of g and then just multiply them? So I have an example here. So if we have f of x equals x and then g of x equals x squared, let's first find what this side would equal. So if we found the derivative of both and then multiplied the derivatives, let's see what that would equal. So what would f prime of x be? 1. And then g prime of x is 2x. So then if I multiply those together, f prime of x times g prime of x equals 1 times 2x, so it equals 2x. Okay, so we'll save that piece of information. That's what we get if we take the derivative of both separately and just multiply them together. Now, that would be this side of the equation. So f prime times g prime equals 2x. We are now going to find the other side of the equation. You'll also see how this is different operation-wise. This side says to find the function f times g first and then take the derivative of that function. So if I find the function f times g, that's taking my f of x times g of x. So that would be x times x squared, which is x cubed. So that's the function f times g. So now if I take the derivative of that, so again, the d dx, that's the Leibniz notation, meaning derivative with respect to x. So if I take the derivative of f times g, that means I'm taking the derivative of x cubed, which is what? 3x squared. Those are not the same. So finding f times g and taking the derivative is not the same as finding the derivative of f and the derivative of g and then multiplying them together. So these are not the same. So what this is showing you is when you have a product of two functions. So for example, when you look at number 1, when it says f of x equals x times e to the x, you cannot find the derivative of x, find the derivative of e to the x, and multiply them together. That is not the correct derivative. That's what this is saying here. So that is why there is a product rule. And you need to know what the rule is. I have it written a couple of different ways. But it says if f and g are both differentiable, then, so first I have it in Leibniz notation. It says if you take the derivative of f times g, this is equal to f times the derivative of g plus g times the derivative of f. Another way to write this, rather than using the Leibniz notation, I could say this is f of x times the derivative of g is g prime plus g of x times the derivative of f is f prime. So that is the product rule. F times g prime plus g times f prime. That's the Leibniz notation. And I include it because you have to know it. Because if you see that notation in a question, you have to know what it means. What? When you see the notation d dx, that means the derivative with respect to x. What? Okay. So then here's a shorthand way to write it, and this is often how I refer to it in class. The derivative with respect to x. So if you have a product, the way I usually refer to it is find your first function, find your second. So that's what the f and the s stand for. F is for the first, and then s is for the second. I mean, if you want to write out all of the f of x and g of x and f prime and g prime, go for it. But this is just a shorthand way. It's simpler in my opinion. So that means the derivative is your first function times the derivative of the second plus the second function times the derivative of the first. So f times s prime plus s times f prime. So putting it into use, let's look at number 1. We have f of x. This is what I would say is maybe one of the most difficult parts of the product rule is you have to recognize when to use it. You have to recognize when you have a product. So when your variable is x, which it normally is x, when you have two things being multiplied that both have x, that is a product. You need the product rule. So quotients are more easily identified. Products, it's easy to overlook a product and then not use the product rule when you're supposed to. So here, I would say this is a product. I have two functions. My first function is x. My second function is e to the x. Okay, because both involve x. So then I'm going to find the derivative of both. So f prime would be the derivative of x, which is what? 1. And then s prime is the derivative of e to the x, which is e to the x. So now putting this together in the product rule, f prime of x is, and the rule is up above, f times s prime. So if you set it up this way, it's this diagonal here. So f times s prime is going to be x times e to the x plus s times f prime, that's the other diagonal product here if you set it up this way. So e to the x times 1. And then you just simplify. So x e to the x plus e to the x is your derivative. Now, if, say this was a problem on an assignment, you're looking in the back of the book, or it's a multiple choice question on the AP test, you may see this, you may not. One other way you may see it is because you have two terms and both terms have e to the x, they would probably factor it out. So they would write it as e to the x times the quantity x plus 1. So you might see it written that way. But again, I would accept this as your answer. If you want to write it this way, that's great. You don't have to. But you do need to know and understand how to simplify when you're working through multiple choice questions. Questions? Okay, so then example 2. For this one, first of all, do we have a product? Yes. Okay. So for the product rule, if again I was setting it up, my first function, my second function, what's the first function? Square root of t. I would probably change that right away and write it as t to the 1/2. So you always want radicals written as a power because then you can apply the power rule to find the derivative. And then what's your second function? That would be the derivative. The second function itself is 1 minus t. All right, what's the derivative of t to the 1/2? Yes, that would be another way you could write it. Yes, yes, you could write it that way. And then s prime, derivative of 1 minus t is negative 1. The derivative of 1 is 0, minus the derivative of t is 1, so negative 1. Okay, so then applying the product rule, f prime of t is going to equal f times s prime, so that would be t to the 1/2 times negative 1 plus second times first prime, s times f prime, so that would be the quantity 1 minus t multiplied by 1/2 t to the negative 1/2. All right, so from here, you could simplify a little bit. Your first term is just negative t to the 1/2. And then you could distribute the 1/2 t to the negative 1/2 to the 1 minus t. So distributing it to the 1, you'd get 1/2 t to the negative 1/2. And then distributing it to the t, you'd have a minus 1/2, and then when you multiply the t's, you add their exponent to be 1 plus negative 1/2, so it'd be t to the positive 1/2. See anything else you could do to simplify? Yeah, these don't cancel. Their exponents are different. One has a negative exponent, one doesn't. Yes, your first term and your last term are like terms. You could combine those. So that would be negative 1/2 or negative 3/2 t to the 1/2, and then plus 1/2 t to the negative 1/2. And again, you can leave it that way if you had wanted to write t to the negative 1/2 as the square root of t in the denominator, that's fine. But what I want to show you, I'm going to leave it like this right now. One thing I want to show you before moving on, you could have done number 2 without using the product rule. How? Okay. Never mind. Yeah, so look at your function. This is what you would have had to do if this was on the assignment yesterday. You still could have done it, because you could start out and distribute the square root of t. So f of t, I'm going to rewrite this though. Square root of t is t to the 1/2 times 1 minus t. So if I distributed t to the 1/2, I'd have t to the 1/2 minus, and then t to the 1/2 times t is t to the 3/2. So that's still f, but now when you find f prime, you no longer need the product rule because you have 2 separate terms. You just use the power rule. Derivative of t to the 1/2 is 1/2 t to the negative 1/2 minus derivative of t to the 3/2 is 3/2 t to the 1/2. Okay, that's exactly what we got, but we did less work here. So what I did is I simplified the function first before taking the derivative. So I distributed the square root of t. I wrote it as t to the 1/2 and distributed. It is, but now my function was originally written as a product. Now it's written as a difference, so I don't need the product rule because I rewrote it first. So why I point that out, both methods work. Neither method is wrong, but if you can simplify a function first so that you don't have to use the product rule, it's easier. Especially when you're simplifying, it's easier. There's less simplifying if you haven't already taken a derivative. Yes, Dylan? I'm saying, yes, check, because if you can simplify first, it's going to be easier to do that before using the product rule. But not everything can be simplified first. So go ahead. I know we have a couple minutes, but find the derivative for number 3. And then there is practice. Really, here's the product rule. The way you're really going to be confident with it is, we could spend, I don't know how many class periods just going through different examples. They're all different. So that's what the practice is. So look at it. We can go over questions tomorrow. But try number 3. So you can at least check 3 before we go. All right, when you're ready, you can look at the screen. I'll put the answer up there. Don't look if you're not done unless you want to spoil your surprise.